we try to share our happiness among all these science practitioners. So among these 41 programs, events under this IISF 2020, many of them are dealing with agriculture, clean air, energy, biodiversity, then building new India, then philosophy in science, waste management, water management. So we tried to bring under this platform the experts who are available with us and who have been generous enough to spare their valuable time with us and discuss on this common platform. So this will definitely give you children the taste of how science is happening around us and why it is happening and how this is taking our country ahead in certain pace. So with this a small introduction on the event which is happening under the name of Students Science Village under ISF 2020. So now we have panelists here, experts. I will give a small brief about each of them so that you know that who are they. And first let me start with Dr. D. Nagesh, Sri Nagesh, who is a chief scientist from our neighboring lab, NGRI. He did his MSc in applied mathematics and then PhD in geophysics, and then currently he is the head of seismological observatory in NGRI. So you know how earthquakes and earth is behaving. We will learn from him today. And sir, we welcome you in this panel. And next I will go to Dr. Pavitra. She is MSc in Life Sciences and she has done her PhD from University of Pune, and she has done her postdoctoral studies in Sweden and Cambridge. And now she is working in CCMB, a lab in CSIR, and she works on cell cycle regulatory mechanisms. And there are many things when you go on in this biodata. So I would also encourage all of you kids that you should visit the websites and know more about the personalities whom we are talking with today. I will also like to introduce our chairman, Dr. Chandrasekharam. He is MSc in chemistry and he is PhD in synthetic chemistry from NEHU. And then PDF he has done from HCU, Taipei, Taiwan, and he was also Alexander Humboldt Fellow from Germany. So with this, I can switch over myself to different panelists from environment and energy. So we have Dr. S. Venkat Mohanji. He is a senior principal scientist in CSR IICT, did his MTech from SV University, and then PhD in environmental engineering from SV University again, and did his PDF under Alexander Humboldt Fellow, Munich, Germany. And he's there working with us on interface of biotechnology and bioenergy, sustainable waste management, waste treatment, remediations. So we'll know more about you, sir, with our discussions. And I go to next our water man, who is very well known in our surroundings and nation altogether, Dr. S. Sridhar. He did his BTech from OU, PhD from Karnataka University, and works on membrane separations process for water treatment, contaminants, and he also develops membranes for dialysis. So we'll know more about him and his research in the coming time. So next we will go to Dr. J. Vatsalarani, who is a principal scientist in IICT, did his MS in chemistry, PhD in chemistry, and she is working on development of rechargeable batteries, mainly magnesium and aluminium. So they are supposed to be the green energy source, and she is also appreciated in one of the energy summit by our Prime Minister, Dr. We have Dr. Raju Reddy, who did his US, Florida and Mississippi, and he is one of the very promising scientists in the field of total synthesis, process chemistry and development of new methodologies. So he is also very instrumental in developing and contributing certain technologies which was relevant in current time of COVID. So we'll talk about this with you in more details, Dr. Raju Reddy. And then I will introduce myself. I'm Dr. Saibal Das. I did my PhD from University of Rennes, France, and then came and joined in IICT Hyderabad, and working on total synthesis, process chemistry, and drug development programs. So with this, let me start the platform, and I will hand over the mic to Dr. Srinagesh. Sir, for our school kids, basically who are watching us today now, and we would like to know how this seismology and the water relevant activities which you carry out, how interesting they are and how our country is getting benefited with this. So I would like to have your words for the kids.
Thank you, Saibal. Good morning to one and all. Before water and earthquakes, one has to know the age on this planet Earth, about the planet Earth. And if you look at the oldest rocks which are available on the surface of the Earth, they date back to 4.54 billion years. Why, for sustainability of human or any other species, we also have to know the timeline where water and oxygen, when did they enter on the planet Earth. That is very, very important. The evidence of life, the first life forms which are seen based on the fossils, is about 3.5 billion years. The photosynthesis reaction, which is based on certain evidences which we have, and which was the oxygen which was being left into the atmosphere, goes back to about 2.4 billion years. And that is the time when water and life started forming. And water, what you see, about 70% of the earth is covered with oceans, that is water. Out of all this water which is available, only 2% of the water resources which is available is fresh water. And most of these out of this 2% which we are talking, 1% of the water is either in the Arctic or on the Antarctic, that's in the poles. And we have got 1% for 7 billion population. That is extremely very important, we have to bear in mind. And we are now heading toward a water crisis, because that 1% of water which we have, 0.5% is in the surface, 0.5% is in the ground. And the biggest challenge for any of us for the sustenance of life itself is how do we overcome the pollutants which are creeping into the water. That is the biggest problem which we are all encountering. And this is what we try to see, that 54% of the landmass of India is water stressed. And most of the fresh water which is used is being pumped out of the ground. And that is where we try to provide solutions in terms of finding out groundwater resources, management, and sustainability of the natural resource, which I think is one of the most precious of all what has been there on this Mother Earth since its evolution. This is exactly what I would like to say, because you talked about water. I think we will talk about water, which is very, very important for all of us, and especially when we see there is sometimes plenty of water available in terms of floods and catastrophe, and many a times you don't even have a bottle of drinking water. So this is what I just wanted to share, that water did not just evolve yesterday. It took a lot of precious commodity, and let us save and see that even one mug of water if we save, and 7 billion people are going to save, it will be in BCM which we can be talking about. This is all I would like to state at the beginning of the year.
Thank you, Dr. Srinagesh. This was really something which is shivering news actually. 1% of water which is available for us, for our uses, and we have to really see how we can preserve it and use it. So we'll discuss more on this. I would now little bit, we have more water experts in the panel. I'll take it in a time later. Now we'll go to Dr. Venkat Mohan. Sir, we have seen that you have been talking to us on energy and waste management. So can you please tell our school children that why this area is so important and why we should develop technologies and do research on this waste management and energy generation?
Thank you, Dr. Saibal. Very good morning to all. I would start with waste is not a waste exactly. Waste is a resource. Basically, now we are depending on fossils for our energy as well as chemical needs. And with the present consumption pattern, we will not be having these resources for future generation, particularly with the same consumption pattern. By 2050, all the resources that presently we are using for our energy and chemicals or materials will get exhausted. So we have to search for alternative feedstock, which is very critical. And we have one of the important feedstock, that is waste, which is being generated from domestic or from industrial activities. So as I told earlier, waste, it's not a waste because it contains significant amount of chemicals in the form of carbon, nitrogen, phosphorus and oxygen, which waste is not, as I told earlier, waste is not a waste. Waste as a resource, it contains significant amount of chemicals in the form of carbon, nitrogen, phosphorus, oxygen. So if we are able to use it in a proper way, we can get the resources, particularly all the fuels or chemicals which right now we are using for our day-to-day activity. So now throughout the globe there is significant attention on circular economy, where circular economy will say about resource recovery and resource efficiency. So wherein waste is one of the important feedstock in this domain, and using biological routes or chemical routes throughout the globe, scientists are working on using waste as a resource, as a feedstock basically, converting it to different forms of energy. Basically, throughout the globe, biomethanization is one of the potential process which is there for almost 100 years. And right now, this process is being treated and able to produce other kinds of fuels in the form of hydrogen and chemicals. So chemicals, basically platform chemicals by biological routes, that can be again converted into different forms of applied materials in the biorefinery approach. So future will be sustainable production as well as sustainable consumption, and circular economy will have to play a very major role in converting waste resources either in the form of solid or liquid or gaseous, including CO2, to value-added products.
Thank you, Dr. Venkat Mohan ji, for your wonderful information. And I really like your statement, what waste is a resource. So this is something we all are working, because resource seems to be going to exhaust by 2050. That's really something we have to think over it. Let us see. Now we will move on to another relevant subject area relevant to waste, but water. So water waste or water waste purification. So let us go to Dr. S. Sridhar, who is here with us today. Dr. Sridhar, you have been working with water more than 2-3 decades now. And what do you think, how progressive we are in water research? And as Dr. Srinagesji told, and Dr. Venkat Mohan told, that water is something which is there only 1% for us. And how do you think the involvement of your research and all, are they connected? And please, Dr. Sridhar.
It's indeed a pleasure to be talking to you about science and technology. Before coming to Dr. Saibal's question, I would like to mention that while I was doing BTech, most of my classmates, they preferred software as a profession, whereas I stayed back and I thought I will continue in science because science was really interesting to me. Chemistry was an interesting subject, and later I took on chemical engineering and then stayed back, and then I thought I will serve my country in whichever way I want, especially through science and technology. So in this regard, I started water purification way back in around 2001, and then I started installing plants for defluoridation of groundwater in Nalgonda, Prakasham, Warangal, and Khammam and other such places which are contaminated. The groundwater is contaminated by excess fluoride, which causes a disease called fluorosis. So this is how I began, and you are all aware of reverse osmosis, which is also there in many of your domestic water purification systems. So this was the technology that we used for defluoridation of groundwater to provide safe drinking water to children and as well as the elderly and the common population in these fluorosis affected villages. Later on, we migrated to nanofiltration, where the membrane, the film, is about 2 to 5 times more open than the reverse osmosis membrane. The pore size, very small openings in the membrane which we cannot see with the naked eye, but it can be seen with a scanning electron microscope. So these pores were about 2 to 5 times more open than the reverse osmosis membrane, and this technology was used for treating moderate tedious groundwater because we didn't want to lose the essential minerals that are present in water. As per BIS standards, less than 500 milligram per liter or ppm of total dissolved solids is sufficient for human consumption and health. Later on, we also went to a process called ultrafiltration, which is about 10 to 100 times more open than the RO membrane. The pores are much more open, and here we started treating surface water. Surface water means lake water, pond water, river water. So these kind of fresh water sources were treated by ultrafiltration, and especially when the floods were affecting Kerala, and then in 2018 and later we had devastation caused by floods in Karnataka, in Maharashtra, Assam, Bihar. We installed several hand pump operated ultrafiltration systems because it operates at a low pressure and it will remove only the pathogens, and it will also remove the turbidity in the water. So you get healthy water which is less than 500 ppm. So clarification and disinfection of the water. So you are not removing any metal ions like fluoride or like arsenic. So here you are only clarifying and disinfecting the surface water. Finally, like coming back to the question posed by Dr. Saibal and also the scarcity of water mentioned by Dr. Sri Nagesh and Dr. Venkat Mohan, we have a solution now called as atmospheric water generator. Only 0.002% of the moisture present in the atmosphere in the form of relative humidity, that much moisture is sufficient to cater to the water needs of the entire globe for one day. And again, this small fraction of the moisture gets replenished, means it gets regenerated because of the natural process of evaporation from seas, oceans and other water bodies present in the world. So in this way, the atmospheric water can be a major source for drinking water, provided it will be remineralized with adequate amount of salts which are essential for the human body. A few years back we saw that schools in Shimla were shut down because of lack of drinking water, as on a hill station it is very difficult to get groundwater and the tourist load was very heavy, and so in such a case the relative humidity is very high, more than 90%. In coastal areas you can see that you will sweat because of the relative humidity present in the air, and there you can generate a lot of drinking water by tapping the moisture, so through a suction fan, and then the humid air meets a condensing surface where the moisture reaches the air reaches dew point and the droplets are formed. They condense and form into a tank where minerals are added, and then you also can use UV or ozone for any secondary contamination and disinfect the water. So in this way, we can save on the groundwater resources as well as on the surface water resources by combining atmospheric water generator with the present membrane technologies like reverse osmosis, nanofiltration and ultrafiltration. Thank you, sir.
What we know is 1% of water availability, but you are working on the other 99% of the water which is available, and we all use at home, as all the kids know, RO membranes. So now we know what this RO membrane doing, and something new technology is ultrafiltration. So we look forward for the proper usage, and the amazing part is you are tapping water from the atmosphere. So this is something I think now people from Dubai and Middle East, where deserts, they would be very happy to use this technology, and they might be also using some of this.
Yes.
So this is what science can do, children. So we are using a tapping which is not available to us, and we are making it as a resource for us. So Dr. Chandrasekharam, you would like to
I
comment
have
something?
a question on behalf of the children watching this. This question is to Dr. Srinagesh and also to Dr. Sridhar. Recently, we have seen a video viral on trading water on Wall Street. You are talking about drinking water, purification for drinking water purposes, but water is also required for irrigation of farmlands and also household needs, etc., etc. In the light of trading water on Wall Street, that means it's going to be a lot of competition among not only within the countries and within the continents. How we are going to address this problem? Thank you.
Thank you, Dr. Chandrasekharam, for this important and valid question. One of the ways, like Dr. Venkat Mohan had mentioned, is through wastewater treatment. So for domestic water, like grey water treatment is one of the solutions, and it can be done quite bioreactor. That is one technology that is coming up, which will combine a biological process and membrane filtration to provide recyclable water within the domestic household. And similarly, in the industrial level, after the biological process of degradation of the COD at BOD levels, the membrane filtration can be a tertiary technology to provide, to reclaim water that can be recycled back to the industry. So in this way, we can have treatment technologies, and also we can try to use such water for processed water in industry as well as for cooling towers. So in this way, lot of water can be recovered, sir. And we also have multiple effect evaporator as the final treatment step after the RO process in industries. And there also the condensed water can be recovered, so leading to zero liquid discharge, as well as we can send the solids, the sludge, for landfill in the future.
The richest nation in the terms of natural resources availability. 70% of the freshwater availability on the landmass is with Canada. That is very, very important, which we should know. We just jokingly say they can start trading. They don't have to trade with oil, but they can trade with water. Especially the container ships would be taking water. In coming to the Indian perspective, as what you write, these are see, at least let us, but it is freely available. Unless you charge, you would never. Change is saying we are going to have extreme events. That means rainfall will have, suppose the annual rainfall of Hyderabad is 64 centimeters in 3 days, like what we saw. Half of the annual rainfall fell in 2 days, and that too in few hours. So it creates a lot of flood. So that's number one. So you have to have ideas put in where the natural recharge takes place and you are going to store the water. That is number one. Second, if you see the prognosis for 2050, 70% of the irrigation which is done in this country is based on fresh water. And we are still using fresh water more and more in such a way that the demand is going to increase. So by 2050 for irrigation, it is said 1072 BCM, billion cubic meters of water is required. And do we have that much of a water? When you look at the water capacity availability in the past 6 decades, we were having 5,000 cubic meters per capita in 1951, which has reduced to 1,600 cubic meters by 2011. So the time has come that we have to have, as my predecessor was saying so, treatment, management, storage, and then we also take into consideration, which is rather very important, is saving. We all put together will get us out from water and meters of annual rainfall, but still they grow the best lemon in the world. So using scarcity, which is, they have turned it into an opportunity. So let's not say that everything is negative. Scarcity makes you to innovate, and that is where we expect all the students to think and come into science, because this is the order of the day.
Thank you, Dr. Srinagesh. This was really encouraging, and our students will definitely mark your words and see what can be Moving on, we'll go to our next participant, scientist, Dr. Pradosh Chakravarti. And here, he is something whom we will request to tell about. See, we were talking about water goes in, and then we have several things in the book where we'll discuss with our biologist experts here. So he is a lipids expert, Chakravarti, that people talk about zero fat, zero diet. So how these oils are, and
before that, I want to interact little bit with the student scientists. First, we are correcting ourselves, and ultimately we are getting some to common people of our country and as a whole, the whole world. So never scared about the failures. So you know that people tell failures are the pillars of success. So here we are, every day we are experiencing failures, but we are trying to overcome that. So coming to Shoaibal's question, that everybody, you know that they are telling about zero fat diet. So whether we should go for that. As students at your growing age, you never do that. Never try to do. So there are certain invisible fat and visible fat. So we cannot go with zero fat diets. But you all know, if you think the oils and fat structure, three OH groups are there in glycerol structure. So all these three OH groups, when they are esterified with some fatty acids, then they get the triacylglycerol, and that is called oils or fats. So if it is mostly the saturated fatty acids, then they are solid at room temperature, we call it fat. And if these are unsaturated fatty acids, then mostly we go means we get the liquid oil. So now you all know this is the source of energy. So if we compare the energy with protein and carbohydrates, we all know that it's more than the double of the energy it gives. So in our diet, oils and fats are the source of energy. Then there are certain essential fatty acids which we cannot generate in our body. So we have to depend on oils and fats. So if we do not take oils and fats, then there will be deficiencies of these essential fatty acids and we will have some physiological problem. And another important fact is the oil-soluble vitamins, A, D, E and K, you all know. So these come from oils and fats. So if we go for zero fat diets, then there always be a problem. So at this age, you don't think anything about zero fat and all. You please take healthy food and a little bit of oils and fats also. Then there are questions will come what oil we should take.
Yes.
And means I'll just give you a small story. Means it's a scientific story. Means say you must be knowing that people are telling saturated fats are not good for health, good for heart particularly. And then in mustard oil there is one fatty acid called erucic acid. That erucic acid is also not good for heart. Now the question comes, the people from Kerala who are taking coconut oil, which is having more of saturated fat, and people from Bengal who are taking only mustard oil for cooking, so do they have more heart attacks? So if you see the statistics, you will find that no, they are also having on an average rate of heart attacks. So scientifically we are telling that coconut oil is not good. Again, mustard oil is not good, but there are lots of controversies. I am not going deep into that. So if mustard oil is not good, if coconut oil is not good, they should have more heart attacks, but it's not happening. Why? One parameter is what I can tell you, that both Keralites and Bengalis, they take lots of fish. And the fish actually contains polyunsaturated fatty acids. So it actually compensates the ill effects of saturated fatty acids. And so if you think very seriously, then who are the scientists? Scientists are our grandmothers. They have actually put this diet. So when you are taking coconut oil, you like coconut oil, you are cooking fish with that. Similarly, the mustard oil when we use this for cooking fish. Now let us come a little bit more about science. So if you see the recommendation by WHO or by American Heart Association, they are telling that saturated, monounsaturated and polyunsaturated, the ratio of the fatty acid should be 1:1.3:1. But no single edible oil is having that fatty acid composition. So very near to this are something like groundnut oil and one new thing which is rice bran oil, sesame oil, and even mustard oil also having monounsaturated fatty acid more. I am talking about our country. So these are the oils we use in our country. Added to that, every oil will have some nutraceuticals. You must be having, you have seen that somebody is coming and telling it contains oryzanol in this advertisement. So there are certain nutraceuticals like oryzanols, phytosterols, sterile esters, then carotenoids, then tocopherols, tocotrienols. These are all present in oil. So we have to take a balance out of it, that what are the fatty acid composition wise, which are the oil which is very good, and which are having more nutraceuticals. Now, as we all know that polyunsaturated fatty acids are good for heart, and in Western world, people are taking these oils, and we also think that that will be very good for our heart. The problem here is most of the Western countries, they take the oil as raw oil, whereas we cook the food with the oil. And generally how we cook, we take the pan, heat it, and pour the oil. So there will be high chance of these polyunsaturated fatty acids to be polymerized. And that is again a question mark. So we have to be very careful to choose our oil based on our cooking habit also. So I think I could answer the questions what you asked me.
Yes, thank you, Dr. Pradosh. It is so. Your two remarks are very encouraging for our kids. Definitely, that failures are pillars of success. Definitely, all of us have encouraged. Means we have experienced failures majorly, I will say, than the success. And this is where we get the strengths. Maybe the pillars are being made like that. And definitely a source of energy in our body, what we learn is oils and fats. So we have to choose rightly, as you are told. So we'll come back to you again, maybe later. I would like to know about our earlier times. People used to use vanaspati oil and all. So I don't know that polymerization you are talking, how it affects. So before going there, now we'll switch over from organism to microorganism, gene level. So we have somebody, as introduced Dr. Pavitra. So she has been working as in CCMB on certain research areas of stem cells, brain organoids. So can you also, I would like to know for our kids, because you are very young, and what motivated you to choose research as your career? So can you please comment on both the things?
Yeah, sure. Thanks a lot. So before I go on to talk about how I got into research and everything, just a fun fact based on what Dr. Pradosh spoke to you. 70% of our brain, in fact, is made up of fats. So if we avoid fats, we are not going to be able to build up our brain, and the activity of the brain is not going to be proper. So how my interest started is like any other school children, most of you now, I found it very difficult to get up early in the morning. I would stay up late at night. And I always started questioning that, why should I get up in the morning? Why can't I kind of, go on sleeping? So the answer would be that you need sunlight, you need energy, So the whole life, if we see, it is based on activity and inactivity. It's always like a cycle. So if you work very hard or if you play very hard, you need so much rest in your body. And that rest actually is for all your organs in the system, right? Your brain needs rest, your heart, of course, cannot rest, but all the other parts of your body requires rest. So I started wondering, what dictates that I should have rest now? You try to wake up as much as you want in the night, but at some point, your brain will just shut off and say that, I need to go to sleep now. So you'll automatically go to sleep. So I was interested in understanding what drives this periodicity, what drives this cycle. Okay, it turns out that in the brain, it's not only the whole chunk of organ, it's these minor cells, which are the smallest unit of any particular organism. That is what dictates, the periodicity of that is what dictates how we survive and how we perform our functions. So that got me interested in understanding how our cells cycle in the body. Sometimes you shed your skin, but when you shed your skin, you grow them back again. So those kind of stuff really interested me. And when we work with complex stuff like understanding how brain works, we often work with all mice and all the other organisms. But there are a lot of differences between us and those organisms, right? So we were interested in asking, how can we make small organs outside our body and use them to address a lot of questions, like, make them like organoids, like you have these robots. How can we make these mini organs outside our body and understand basic biological development, how it can be used to model diseases like cancers, and how we can come up with different drug therapies and targets for treating those diseases. So I hope I answered your question.
For your comments and remarks, and I hope school children, you got the answer that why she got fascinated about science and why she is doing it, and she is now among the experts panel here. And we really want that many of you who are watching us today take up science and contribute to this country's development. So now I move on to Dr. Anthony, who is here with us, and he is one of the first order batsmen who has contributed in the COVID fight of our country, and I congratulate him from heart for the development.
For having me. I'm very happy to talk to the children and who are watching the program today. So if you think our bodies, if you just think about the most complicated chemical industry in the world, what it could be. The most complicated chemical industry in the world is our own body, basically. It does all types of chemistry. Can you imagine the kind of foods what we take? We take simple sugars to complicated food, proteins, like Pradosh said, a lot of oils, and then all this are converted into required material, like what Pavitra said, that we need to have this fat, specific fat. So the fat what we eat is not directly going to the brain, but it is going to be converted by the reactors, the so-called the reactors. They are the enzymes in our body, and there are several thousands of enzymes in our body which does various reactions and take the raw materials, convert that into a valuable material in our body. So enzymes are the chemical reactors that do the chemistry. So the very interesting part, I think, now the future of the industry, the real industry, the pharmaceutical industry or agro industry is going to be in terms of biology related, basically. So we have seen that there's a lot of, again, we have seen Dr. Sri Ganesh talking about the water pollution. Sridhar has talked about the water pollution, and most of the water pollution is coming from the industries, basically, because we are becoming consumer people. We consume a lot, so we need to have new products to be made. So a lot of chemical industries are being established for pharmaceuticals and for all our day-to-day products, basically. So, and these actually contribute for the pollution. So now people are thinking that are there any greener ways how we can alternatively use the renewable sources so that we don't pollute the water bodies, and still we have the luxury of the products what we want. So for this, people have started looking at the enzymes, because we know, as I told you, enzymes are the good factories. They selectively make molecules what they want in our body. And like humans, we have thousands and, not even thousands, millions of organisms like bacteria, fungus, and so many of them, they exist in various conditions. So they also have chemical reactors like enzymes. And so we can pick up each of them, basically, and then study their chemistry and apply them in the industry, basically. They are called, and then we ferment them in the lab and produce a particular reactor in the large scale and apply it for chemical conversions. And for your question, how fascinated did I become in COVID research? I think it's not a fascination. I think it's a need. So I think, when COVID was declared and every country was looking for its own needs and requirements, and unfortunately India actually imports a lot of these reagents that include some enzymes which actually are required for diagnosis of COVID. And particularly, I'm sure children must have heard the method called RT-PCR, reverse transcriptase polymerase chain reaction. So what it does is it takes the RNA of the COVID present in our swab samples, then that is used by the enzymes to amplify it, and then we look by a signal, a method, a fluorescence method, and then we look at a signal. If there is a COVID RNA in our body, the signal goes up. For this, 3 enzymes are required, and those enzymes, at least 2 of them are completely imported in India before the COVID started. So we said, being in a government organization, we felt it was responsible on our part to provide some alternatives before the old world copes up with the needs of the enzymes. So we started making the enzymes in the lab, and then we have tested, we have established the method of COVID test in the lab, and we provided this technology to a company. So that's how, we have worked with the diagnostic development for the COVID-19.
Wonderful, Dr. Anthony, to see your technology is being used and within so short spell of time. So kids, now you know how enzymes are also important, and as he says, it reminds me of a small story. Once one mechanic asked a medical doctor, that you also do the same thing as I do, but why I am paid less and you are paid more? So the doctor smiled and he answered very politely that try to make and repair your vehicle when it is in switch on mode. So that says everything. Our body is such an industry, chemical industry, as he rightly put up, that all the chemical reactions are happening simultaneously. So resource, energy, and then application, waste management, everything is done in our body. So if we can learn everything about our body, how it works, I think we know everything about the world. So with this thought, now I will move on again to somebody who is very much special, who is working on green energy source. And I would request Dr. Vatsala Rani to speak on her research work and her fascination towards this subject, so that our kids know more about what green batteries are about. Dr. Vatsala. Thank you, Saibal sir.
Yeah. Hello, students. So today I'll be talking about energy source, especially batteries. As Saibal said, green batteries. So what are green batteries? I'll tell you about green batteries later. First, let me tell you about batteries. Batteries are mobile electrical energy source. They are not a device, they are electrical energy source. This energy source, it is so comfortable, you can take it to any corner, any nook and corner. Even in space, you can take this electrical energy source and you can power so many gadgets. As technology is advancing, you need more and more such electrical energy sources. Now, let us come to these green batteries, what Saibal has told us now. Are the existing batteries not green batteries? Let me tell you, the battery which we are using these days, the lead acid battery, it was innovated 150 years back. Then there was no problem of this green. Why? Green indirectly means green is not a green color, battery is not green in color. Green here means the materials which we are using in the battery, they have to be sustainable, they have to be eco-friendly, they have to be safe, and last but not the least, 100% recyclable. So when a battery is having all these features like sustainability. Now sustainability, what does sustainability mean here? Sustainability means all the materials which we are using in the battery, they are abundantly available in our earth crust. These batteries are called sustainable batteries. Now you may ask the question, Madam, are the existing batteries not sustainable? Are they not really the material which we are using in this battery, is it not abundant? For example, let us take the lithium battery. Of course, lithium battery is the advanced battery, and because of lithium battery, we are able to make a light mobile phone as well as laptop. But children, remember, when you are exploiting any energy source, remember the materials also in this battery should be abundant. Now, if you take the lithium source, its availability is 0.07% in earth crust. So it is really, it comes under this scarce element. So you are supposed to not exploit such elements. You have to use them very judiciously. And next, let us come to eco-friendly. Now, are the existing batteries not eco-friendly? I'll tell you about lead-acid battery story. Lead-acid battery was developed 150 years back. Then the technology was such that we didn't have a mobile electrical energy source. So the material which was easily available and by the material with which you were able to make a battery very easily, that was lead. Lead element melts at nominal around 160 or around 200 degrees centigrade. So it was very easy to make a battery with lead acid battery, with lead metal. So we had made this lead acid battery, and it is one of the cheapest battery. If you compare all the batteries, we have nickel metal hydride, we have lithium battery, dry cell. So lead acid battery is the cheapest. So what we have done is we have been using it extensively. We are using lead acid batteries everywhere. So it's 60 to 70% battery market is still lead acid battery. So now, as we are using it extensively, we are using it and we are throwing it everywhere. So once this lead, which is a heavy metal, it comes in contact with water. So the water, it dissolves the lead salts and it contaminates all the water bodies. And as you know, lead is the heavy metal, so it is highly toxic. So it is we who have made it toxic. We are using it extensively. So that is another issue, eco-friendly. Since the materials are not eco-friendly, we have to use it very judiciously and we have to see that it is 100% recycled. And next comes safety. Safety of a device is also, safety of energy source is very important. Now, when I'm saying energy source, it has so much of electrical energy stored in it. So you should not abuse these batteries. These batteries are made for certain applications. So you have to use them in a very, very proper way. See, battery, it uses electrical energy. Now, as it is, you can get energy from diesel or petrol or even wood. But these energy sources, they contaminate or they pollute the environment. So what you have, this electrical energy, it does not. It is a very safe or eco-friendly form of energy. So in a battery, what we do, the chemical energy is converted into electrical energy whenever you are using. Okay, whenever you want the electrical energy, we convert this chemical energy into electrical energy and we use. So now here, when it comes to safety, I'm talking about, as you all might have heard about, this lithium battery or devices where lithium battery is used. You see they just catch fire or they explode. That is because of we abusing it. Most of the time, we either overcharge it or we happen to use it in a different manner, or as per the guidelines which are given to us, we don't use them. That's why it such flammability or explosion of batteries are taking place. But again, there is an issue of safety, of course. So what next is recycling. Recycling of the battery. So recycling is we are giving back the material again to in its natural form. When we are making a battery, we purify these materials and we accommodate in a battery and we make the battery. So recycling is what we do. Again, we bring back to its, we use it back in the battery. So if we recycle, what will happen? We will avoid this pollution or contamination of water. Okay. Now, what we have done in IICT, that is green batteries. We have started working on these green batteries. So what we have done, we have taken materials which are abundant. For example, we have taken magnesium and aluminium. Magnesium is third most abundant, aluminium which is eighth most abundant element. So we have started working with these materials. And when we talk about eco-friendliness, so the electrolyte which we have chosen in these batteries, every battery needs electrolyte. So the electrolyte which we have chosen, it is an ionic liquid which is called green solvent. The electrolyte which is in lithium battery, that is actually the major cause for the flames in the lithium battery. So what we have done, we have taken there in the lithium battery, we are using organic electrolytes. And here we use the safe ionic liquids. So they are safe because their boiling point is around 250 degrees centigrade. So they do not vaporize easily and they are not flammable. The structure of this ionic liquid is such that it is not flammable. And safety concerns, because this electrolyte, it is safe. So we say even a fully charged battery, if we pierce it or cut it open, then also this battery does not explode. So recyclability, this battery is 100% recyclable. Yeah. Thank you, Saibal.
Is the energy source portability, which is done in the form of batteries. And here comes a challenge for all of you in future, as Dr. Vatsala told, that all the materials or the chemicals which like metals like lead, aluminium, magnesium, they are in abundance now, but it may not be there for us tomorrow. So we have to look for developing certain energy source and storage, safe storage, as Dr. Vatsala told. So this is a big challenge again for all of us of this generation, that to develop energy source, energy storage for our coming years. So this is something we learned today, and we will discuss more on that, because I have a feeling that why not there will be an energy source in our body, external device which has energy source, and it keeps our body running in the form of I don't know what. So this is something all of you are there to see. So we'll wait for that. And before I go to the next one, I would say a batsman like Anthony was the first order batsman. So we have somebody who slogs. And Dr. Raji Reddy is one of them, who is an organic chemist, and he is doing a wonderful job in development of organic molecules preparations, the process, and now he has contributed definitely towards the development of COVID drug, and we will learn more about it. And I would request Dr. Raji Reddy to also tell that what makes you come to the area of research, and what you are doing in the COVID contributions for the country. Dr. Raji Reddy.
Dr. Saibal, greetings to all the students and children watching this program today. Till now, you have heard about water, environment, biology, energy sources, batteries, oils and fats. In daily life, so many things, these are important things around us. So you have heard about all these things. Now, what about to have all these materials? So what I'm going to do in next 5 to 6 minutes, that the importance of chemistry and how it is related to all these branches, and what we are doing in our lab at CSIR IICT. So first, let us see that, I became a scientist here by developing some interest in chemistry. So then why chemistry is important? All of you know that everything is chemistry, but just for 5-10 minutes, let us be in chemistry world. So you imagine that whether in between you or you and your friends or around you, everything is chemistry. So I wanted to show a few examples, and then we'll go further how you can also contribute in this field. So for example, when you are studying now in 9th class or 10th, 11th grades, all of you must have studying chemistry, and this, as soon as you feel that somebody says that it is a chemical, all of a sudden chemical means everybody thinks that it is something smelly compound, it is bad for the environment, then you feel that we should keep away from the chemicals. But it's not the case. So for example, I wanted to give the best example. Wherever I go to the school children inspiration programs, I take this is the only best example. If you take this water bottle, without water nobody can live. Like all living organisms require this chemical. I say this is a chemical because all of you know what is the formula of water. H2O, hydrogen, oxygen. And where is this from, hydrogen and oxygen? This is all of you know from periodic table, right? And this is again chemistry. And now you take the cap of this bottle. This is again made of a polymer, again a chemical, and for this you have this green color. So from where this green color came? It is again from pigments. That is also a chemical. So like this, you take any examples around you. You have a pen in your pocket. Again, you have ink. Ink is made up of blue ink, red ink, black ink. All this is depending on the variation of chemicals, the pigment we are using in that, you will get that color. So you name any item or anything you name. Take your body now. Your body is full of thousands of chemical reactions. If there is no reaction, you cannot walk. If there is no reaction, you cannot look. If there is no reaction, you cannot taste. Every reaction again involves between the chemicals. So that is why you can actually say that your body is a walking periodic table. Your body is carrying lot of elements. You have carbon, carbohydrates, hydrogen, oxygen. You have iron in your body. You have whatnot. You can copper little bit in your body. So all these things to put together only a living organ. So what we can say that chemistry is everywhere. Without chemistry, we can't live. Now you understand little bit probably, like if now next go to plants. Within the plants also they are making food, processing, this all photosynthesis, everything is again chemistry, right? You without chemical terminology name, you cannot imagine this kind of activities. You are constructing buildings. You have iron, iron formula Fe, and you have cement, it is a mixture of few other things, and you have everything, paintings, everything is again chemistry. So now come to little bit specialized subject, what we are doing at CSIR ICT, taking this chemistry as a knowledge. So for our human health care, we need medicines. So from where these are coming? The initial root for this is a molecule. So molecule it may comes from nature, it may made in a laboratory. So but if it coming from nature, when we are identified that nature produced molecule is working for a particular disease, we cannot every day get from the nature. Best example we can take that we have urea. Urea is used in metric ton scale in all our paddy fields. All of you know that various fields to grow the plants and all these things we use urea. So but urea is initially when it was discovered, from where it is identified in 1727, urea is identified from urine. So is it possible to extract this much urea from urine? No way. So you need to have alternate source. So after 100 years, in 1828, Frederick Wohler discovered that in laboratory we can make urea starting from easily abundantly available compounds on the earth. So from there he produced urea, and today lot of urea plants across the world, and they are producing ton scale urea. And another simple example we can take camphor. How much camphor we are burning every day, and various other places also we are using this camphor. Again, it is a natural product. It comes from a tree. So our required camphor, we cannot cut all the trees and take camphor what we need for all the world population. So again, there is a synthesis or process which we can make in the laboratory. So these are the best two examples we can take, and if we go on, there are hundreds of examples. Now come to your healthcare product. Suppose the best example we can take is a paracetamol. All of you know that paracetamol, whenever we get fever or any body pains, some kind of headache or something, all of us take paracetamol. So if you take the paracetamol dose, again it is a 500 600 milligrams or 650 milligram tablet per day we have to take, because it active in our body for 6 to 8 hours. So per day you need how much quantity, and like that you calculate for whole world population requirement of paracetamol. From where we can get this paracetamol? It has to be prepared in the laboratory, the active pharmaceutical ingredient it is called, and then after that it will be formulated in the form of tablets. So this is also you require in ton scale. For this, we need to identify the best available method for the synthesis in a cost effective manner, and it should not pollute the environment while we are producing. We have to keep several things in mind. So that is where in future, if we have self-reliance technologies for these things, still we are dependent, we are making paracetamol in our country, but still there is a provision for improvement or to make in a better way. You can take best example, olden days, radio used to be, I don't know how many of you have seen radio in your old grandfather's time. They used to have radio itself a big TV size, today TV size. But today, in your mobile, you can have everything starting from camera, radio, whatnot. So this is because of development of technologies, development of science, development of various research topics. So for this, coming to back to again healthcare, so you can still further improve what are the existing method. You have drugs, we can still make them in a better way and make it cheaper. This is again, it is on all of us that to need our country sufficiency of the medicines, we should not depend on it. So we need our own technologies, own processes, not only for developing the processes for the available drugs, but you also think of new medicines, because every day there are new diseases are coming up, diseases are identified. You can see the best example now, COVID-19. Nobody thought that corona virus will come in this big way, and the entire world is affected now, all of you know, and this is causing COVID-19. And immediately all the scientists reacted to this and started doing research, and at least now we have identified some of the treatment methods to treat this. Still many organizations, more than 100 laboratories are working on vaccine development. So like this, we have to keep on protect ourselves from all these various diseases, and when it happens, only if you have science development it will happen. So therefore, children, the future, the development of our country, then obviously globally development will be on your shoulder. Technology is very much important for any country development. If you have science and technology within our country, we can have our own things. We no need to depend on any other countries for any kind of products. It may be electronics, it may be medicines, it may be anything. I'm not saying only that chemistry and these chemical products are, but again these chemical products are involved everywhere. Even if you want to make electronic item, you need a material. You need a stable to the light, stable to the sun, everything, those kind of materials. Again, material is a kind of a chemical. So everywhere these materials are required. Therefore, at least some of you could become in future scientists of this country for development of all these products or drug discovery participations, any kind of program. You can have a lot of opportunities if you come to the science, because you are learning science. You should use that knowledge for research purpose, for the development of something, and always you should have a feeling from now onwards that I should contribute something to this nation, or I should contribute something to this country. There are various problems, not only health issues, there are various problems. Even you can contribute if you are interested of various things. So wherever you have interest, only thing that you need to think in perspective of science and how we can improvise the quality of life of human being. So with these few words, I my best wishes to all of you. Looking forward to see at least some of you in the future as a scientist.
Thank you, Dr. Rajareddy, for your very elaborated explanation about chemistry. I'm pretty sure when we were kids, like the kids students watching us, and we were afraid about chemicals. As soon as the name chemistry comes, we think it is all hazardous, dangerous. So now we know from your brief, lecture that chemistry is everywhere, and we should know how to utilize it properly to enjoy from the fruits of chemistry. And very fortunately, I would say, students, that today in this forum we have personalities who has contributed tremendously in this difficult time of COVID. So we have Dr. Sridhar, who has made the prevention kits like masks and shields for our population. Then we have Dr. Anthony, who has contributed for the diagnostics. So whether you have got COVID or not, with the PCR kit technology, we can know. And then you have, just now you heard from Dr. Rajareddy that we have developed the drugs which are probably saving a lot of lives across the world and India altogether. So you saw how science is important, and in the difficult times how scientists are working in the lockdown period and all what is explained by Dr. Rajareddy. So now moving ahead, I would ask our Dr. Chandrasekharam to speak about science and technology, how it is useful as a whole for acquiring the Atmanirbharta of our country. A very short one. For example, how science is science for self-reliance, for energy, as we have heard science reliance in health, and then natural resources. So your comments, and I open the forum for your comments. Anybody can put your words.
So children, I once again welcome you all to this India International Science Festival 2020. The theme of this year IISF is Science for Self-Reliant India and Global Welfare. We all should remember that the Self-Reliant India or Atmanirbhar Bharat is for the sustenance of our country and development of indigenous technologies sufficient for our country. But it is not to insulate ourselves from the outside world. Second thing is, I would brief few technologies developed by CSIR towards Atmanirbhar Bharat. For any country to maintain democracy, you need to conduct fair elections. You may be knowing, after your parents or elders, after voting, they come and show you a mark on their finger, that black mark. I don't know how many of you know that ink, that indelible ink, is the technology is made by CSIR, that is Council of Scientific and Industrial Research. Similarly, the white revolution, the storage of milk for future, making milk into powder or concentrated form, that technology is also transferred by CSIR to the industries. Similarly, there are several technologies transferred to industries towards Atmanirbhar Bharat. But now I would like to emphasize how you can play a role towards Atmanirbhar Bharat. Generally, your parents, while you study from 8th class, 9th class, 10th class, they say, oh, these 3 years are very important. You should work very hard to get admission in +2 in a very good college. Then you study very seriously and you go to +2. Again, parents say that, yes, we have come to +2. This is really a turning point to get admission into engineering or medicine. Again, you have to work hard. Followed by other like engineering, medicine, or BSc or MSc. So throughout there is a lot of stress on children to study hard and memorize and write the exam. But there is a trick if you want to enjoy it. You have a goal, you set a goal that I want to contribute towards Atmanirbhar Bharat. I want to make India self-reliant. When you set the goal, you enjoy everything because your main aim is to contribute towards the entire country. You will get recognition, you will get the name, fame and all. So when you keep that in mind, you will work very hard and you will enjoy your studies. And after MSc or after MTech, if you want to take PhD as your career, there is one organization, Council of Scientific and Industrial Research, who will provide you a good amount of fellowship. You can learn and you can also earn. For about 5 years, CSIR provides a fellowship, good amount of fellowships for your sustenance, and you can do a lot of research of your interest, whatever topic you select. You can finish 5 years research, then you can also go to one of the branded institutes for postdoc, either within India, also outside the country, and you get the best training. And then come back. For coming back again, Department of Science and Technology or SCRB, they have a lot of DST, they have a lot of fellowships to welcome you back to India and work with very good amount of fellowship. Before you get a permanent job in a permanent placement in any academic or any other institute. So that way you can come back and start your career, choose a career and continue your research, and then meanwhile you can find an institute of your choice where the discipline of your choice is carried out, and you can join, get the placement and become a good scientist and contribute to the nation. This is how every child should dream of and become a good citizen and good add value to the country and make India self-reliant India or Atmanirbhar Bharat. Thank you very much.
Thank you, Dr. Chandrasekharam, our students who are watching us. And now if you want to take up research, the organization which pays you for your learning, for your sustenance, that is CSIR. And here all of us who are sitting here in this panel today as an experts, we all belong to this lovely organization which supports R&D of this country since last 7 decades. I would request Dr. Sri Nagesh to comment on the self-reliant perspective from your end, sir.
All the efforts what we heard today from our scientists, very clearly the science is focused towards self-reliance. And if you see, the science has developed only by observation, data, hypothesizing, and then theoretization, and then trying to prove through experiments. So I request all the students that if India needs to be self-reliant, it is not only in technology but also scientific development and innovation. They all go hand in hand. And this is a great challenge, and the future is yours. And a lot more needs to be done in terms of natural resources, a resilient planet Earth, resilient from natural hazards especially, whether it's earthquakes, whether it's floods, whether it's rains and other aspects. So we need a lot more contribution for self-reliance in terms of innovation, and that is where CSIR has been doing, and we have been all working in these areas and goals. And to say one little thing which I would like to give you an example, uranium happens to be a natural source for generating clean energy, that is nuclear energy. And India has been, and the CSIR and GRI has been working towards it for finding out the uranium deposits, because 90% of the uranium which is used for this clean energy is imported. And usually the nations don't try to partner because, for other reasons, the nuclear program can be diverted. So we have been contributing in finding the uranium natural resources so that the future is going to have a lot more clean energy, and also trying to find out natural water resources and trying to find remediation measures from natural geogenic pollutants using simple technologies which are available so that you are going to have a safe and secure life in the future. Thank you very much.
Thank you, Dr. Srinagesh, for your time. And I know you are in hurry. And we thank from the organizers for your involvement in IISF 2020. Thank you, sir, for your time.
Thank you.
Now we'll move on to Dr. Venkat Mohan for giving his perspective on the self-reliant part of water or bio-waste energy.
So thank you, Dr. Saibal. To add to what Dr. Srinagesh has told, self-reliant India is at present one of the critical things. Basically, when we look into environment also, for past 200 years, the situation is changing significantly. When we are practicing our age-old tradition, nothing is a waste in a village. Everything is reused in a circular mode of operation. But right now, because we are little bit disturbing the system, so we are going with a linear economy, where we are wasting our resources. So self-reliant system will say about self-sustainable systems, I would like to say, with respect to environmental perspective, where we have to go with self-sustainable systems in future, where everything should be done in a circular mode of operation by taking natural whatever is happening in the nature into consideration. Particularly, we have to integrate all the process, photosynthesis process, as well as other whatever science is developing in a proper way, in an optimized way, in a loops which will be closed and all resources will be used. So that kind of systems are very essential in future for all our resources, as well as to sustain the environment in a pristine way and to go back. Particularly when we look into for past during the COVID period, there is significant learning we can get from environmental concern, wherein during the lockdown period, we are able to go back with respect to our biological regeneration system of Earth. Basically, last year, Earth Overshoot Day, which tells about Earth's capacity to regenerate back, is on July somewhere between 21st or 27. But incidentally, after quite long years, first time able to go back reach self that should have also the way of relating the environment to say the self-reliant India, the theme of this festival is very apt and very important for going with a sustainable future for young generation and students. Particularly, students can do a lot of things because they can learn from nature and they can implement in their science career. To adopt the sustainable means, and I would wish them all the best to take science as their career towards sustaining the globe as well as India. Thank you.
Thank you. So now we move on to Dr. Pavitra, and we will try to learn her insight on self-reliant India and put her insight. Thank you.
So thank you all. So in this context of self-reliant India in the field of healthcare specifically, if we see, we have a huge wealth in the form of our genetic background. So we have two different types of genetic backgrounds present in different populations, like people from South India, North India, different parts of India. So each of us has a particular genetic makeup which makes us predisposed to one particular disease, whereas it makes us resistant to another kind of disease. So if we can use all this knowledge from within India to come up with a big database or health database, we'll be able to achieve a healthier country, and for which we can use all these resources. We can pool all our resources. We are trying to do that by establishing a lot of consortiums and groups which work together from different parts of the country and look at things which are indigenous to our population. So we know that not all 5 fingers are the same. So similarly, what is useful for us as a country might not be the same which is being used elsewhere. So if we can target our population specific or indigenous specific drugs and treatments, I think it will be really useful to make a healthier country, and it will cater to Atmanirbhar India as well.
Thank you, Dr. Pavitra, for that. Yes, managing data and utilizing it properly indigenously will help us really to move ahead. Let us see, our future generation has a lot of work to compile all the data and analyze all the data. So this is something going to be very big in the coming days. So all of you should be geared up for AI and MI based artificial intelligence and machine learning research also. This will be very interesting in the coming decades to come. Dr. Chandrasekharam, you wanted to note something here at this point.
I have one question to Dr. Sridhar. As you know, the Atmanirbhar Bharat, the idea and the need was mainly generated during COVID pandemic, particularly when we do not know what is the treatment, what is the vaccine, what are the protective equipments, and include the even PPEs, personal protective equipments, were imported that time, when the supply chain was almost stopped, because most of the flights were not coming to India, and there was no transportation within the states, and no transportation. So during that time, throughout India, in the name of Atmanirbhar Bharat, all small and medium scale industries were given a task to prepare PPEs. After certification, after our CSR laboratories have got certified materials to get those PPEs. Over a period of time, by July or so, we have produced lakhs of PPEs, and also we have exported to other countries. So in such scenario, I remember Dr. Sridhar, even during the lockdown time, you and your team are coming to the laboratory and trying to prepare or make the technology for the masks. And also, we all know that the technology you have generated or made is transferred to CIPLA Foundation, and CIPLA Foundation is generous to support as a part of corporate social responsibility to manufacture 1 lakh of masks to provide free of cost to underprivileged public of India to prevent spread of the disease. I would like to know, I would like you to throw some light how you overcome during lockdown time for the development of the technology of sans masks. Thank you.
Thank you very much, Dr. Chandrasekharam. I think it's a very important, valid point that you have made. And so, children, it's very important for us to be independent and self-reliant. And I will give you not just the mask example, but one more example later. Coming to the mask example, initially what we did is we started off by using cotton layers on either side, and then we had a hydrophobic layer of polypropylene in between, and we made a 3-layer mask. So here you can see, actually this is a 4-layer mask, and this is called as sans. And the idea was that last year during the air pollution at Delhi, I tried to wear one of our membranes, ultrafiltration membrane, single layer membrane, but I was not able to breathe. Then later, I thought that we should have more open layers and create a tortuous or strenuous path for the respiratory droplet, which is the medium for the virus, which carries the virus up to our nasal cavity. So in this regard, we designed a mask called sans, where we have actually 4 layers. On either side, we have got cotton layers for comfort and tight porosity, and then in the center we have got the active layers, 2 hydrophobic layers. One is made up of polyester and the other is made up of polypropylene non-woven fabric. So you children can also make masks at your home. You can make 10 masks, 5 for your family, and with 2 cotton layers on either side, 1 cotton layer each on either side, and a non-woven polypropylene. If you remember, waiters and cooks in restaurant wear a polypropylene cap. So it is made of similar material and it is quite easily available, while the other layer is a little bit proprietary, which is made up of polyester. The polypropylene layer is easily available, and you can make a 3-layer mask, and the other 5 masks apart from your family you can distribute to the milkman, to the municipality worker, and to the courier boy, to the maid coming to your home for work. So in this way you can also protect 5 more people. And in this regard, when we made this 4-layer mask and then we tested it by candle extinguishing test as well as hold up of water, because respiratory droplets should not go through the mask, so it was very successful. And so this configuration, finally we scaled up to a larger production level, and in this way we were able to provide masks in more than 10 districts of Telangana through CIPLA funding, CIPLA Foundation funding, as mentioned by Dr. Chandrasekaram. And so far we have been able to distribute nearly 35,000 masks in several areas of Telangana, and the children are comfortable and the masks are highly breathable, and you can see that there is not much change when I am able to speak also to all of you, and there is not much change because there is some space left in the front so that the mask does not touch your lips and you are able to breathe freely, and at the same time you have to be comfortable. The mask has to be affordable, which means that it should not cost more than 20-25 rupees. So it was made for about 15 rupees in total, including the elastic and the stitching charges. And so this was also transferred to other NGOs like Ambuja Cement Foundation and Mandeshi Foundation, so that they can generate employment and revenue for MSMEs. Coming to the other self-reliant part of our work, a few years back, we had one of our departments approaching us for medical grade water. So in this regard, we thought, why should we always depend upon a system which costs several lakhs to generate medical grade water? And this water is not for drinking, but it is used in dialysis, where patients suffer from kidney failure. So this water is used for making the buffer solution that collects the impurities like urea and other toxins. So this water we made by using a double stage RO system plus a resin. So in this manner we have been able to serve the patients suffering from chronic kidney disease, and this system was this technology was again transferred to an entrepreneur, and with his help we have been able to serve about 50,000 patients in Nephroplus with ultra pure water for dialysis application. And this water is also useful for other applications like soil test kit, and it has, for which it has been transferred to Plantris Ventures, and it is also being used in different labs including IICT, CCMB and CGCRI for biological cultures, to grow cultures, because this water should not contain any endotoxins or any salts. So in this way we have made a much low cost system costing only about 80,000 rupees, which is the selling price, compared to 5 lakhs or up to 15 lakhs charged by multinational companies, and again they charge 1 lakh per year for the maintenance, and several systems are lying idle because there is nobody to come and service them. So in this way we created a much more simpler system which is easier to maintain, and therefore like Dr. Chandrasekaram mentioned and Dr. Saibal has been persisting with this word Atmanirbhar Bharat, we are now able to produce our own medical grade water and our own masks too, which is the first line of defense to protect you from COVID-19. Thank you.
Thank you, Dr. Sridhar, for your very detailed explanation. I think now kids are very well aware how we can have the first line of defense, the mask, which is just explained by Dr. Sridhar. And you saw how we can get medical grade water for being self-reliant, so that we are not bringing anything out of country inside. Now I would request Dr. Pradosh to give your insight on this self-reliant on when it comes to oil technology. So are we self-reliant, or where we are on this aspect? Dr.
Thank you, Saibal, for raising a very relevant question. Actually, for our country's requirement, we are totally dependent on foreign countries. So more than 50% of our oils and fats requirements we import. So the self-reliant question in this particular area of science is very, very important. So let me tell you kids how the scientists think about a problem. So when we saw that, means we all know India is the second largest producer of paddy. So we thought that from the bran, rice bran, so that is just when we remove the husk, we get the brown rice. And a very thin layer of that we can remove by polishing, and that is called bran. And that bran contains very good amount of oil and very highly nutritious oil. But it was going to soap making because there was no technology. So we actually had a survey throughout the country. We went many states and found that there was a problem of degumming. So we thought how we can solve the problem.